Hi, and welcome to the sixth episode of our series in which we present Agentforce vibes. My name is Philippe Ozil, I'm a developer advocate at Salesforce. In a previous episode, we saw how to enforce code quality and security. In this episode, we'll focus on migrating from Aura to Lightning Web Components with Agentforce vibes. I'll give you a bit of context about Aura and Lightning Web Components. We'll take a look at the Salesforce DX MCP tools that we'll use, and we'll go through a practical example of a migration using a sample app. Aura, formerly known as Lightning Aura Components, is a legacy UI framework that we introduced in 2014. Aura became deprecated with the launch of Lightning Web Components, or LWC, in 2018, a modern and web standard-based replacement. Yet, despite the many performance and security benefits of LWC, tens of thousands of Aura components remain in use nowadays due to the cost of migrating. Fortunately for us, this is about to change thanks to Agentforce vibes. Before we start with the migration process, let's take a second to look at the tools that we'll need. The Aura Experts and LWC Experts toolset from the Salesforce DX MCP server contain a number of tools that work in conjunction to support the migration from Aura to LWC. Some of these tools are still in beta at the time of recording, so you'll have to enable non-GA tools by specifying the Allow Non-GA tool flag in your MCP server configuration. As always, you can refer to the second episode of this series for more details about how to configure your MCP server. Now that we've covered the configuration part, let's take a look at how the tools work. It all starts with the user sending a prompt that requests a migration from an Aura component to LWC. The dev agent calls the Orchestrate Aura migration tool to build a plan for the migration steps. It then calls the Create Aura Blueprint Draft tool to build a draft blueprint from the Aura component. This blueprint is a YAML file that describes the component. It holds information like basic purpose of the component, technical details like references, child components, data being used, interactions, states, and more. The Aura draft is then enhanced by another tool, Enhanced Aura Blueprint Draft. Next, the Aura blueprint is converted into LWC blueprint with Transition PRD to LWC tool. Next, the LWC is created from the LWC blueprint with Create LWC component from PRD. Finally, the Guide Design General Tools runs to apply final styling touches to the LWC with SLDS, the Salesforce Line Design System. Now that we know about the theory, let's put this knowledge into practice. For the purpose of this demo, we're going to use Dreamhouse, one of our oldest sample apps. We've migrated the app to LWC long ago, but we kept the original Aura version, and this is what we'll use for our migration. This app showcases a fictitious real estate broker. You can browse properties with various filters. All of the components in this page are custom Aura components. For today's demo, we're going to migrate the property summary component. I'm now in VS Code looking at the source of my Aura component, and I'm going to kick off the migration with this simple prompt. Note that I'm using context to target the right Aura component. At this point, I'm going to fast forward the video. This task is now complete and we can see the summary here. The 6 actions that we described earlier were chained. They produce the Aura blueprint that you can see here, and here is our LWC. Let's deploy it and try it out. To speed up things, I've manually renamed the LWC so that we can see it side by side with its Aura counterpart, and I've added it to our Lightning page. Let's refresh our property finder page. You can see our 2 components, but the LWC doesn't update when we select a property. Let's go back to VS Code to figure out why. If we look more carefully at the task summary, you'll notice that the select S-object event was not migrated. This is because this is a system event that is Aura specific. Fortunately for us, we have an LWC equivalent. That's the Lightning Message Service. What we need to do is to replace the select S-object event by a Lightning message, and that's what we're going to ask our dev agent to do. We'll apply the change to 3 components: the Aura property tile, the Aura property summary, and the Aura property LWC. Fast forward, we can see our message channel here, and our components have been updated to use the message. Let's deploy our changes and test them. This time, you can see that the property summary LWC updates when we select a property. There's just one last issue, and that's the style. You can see that it's broken and it's not aligned with the Aura component. So let's go back to VS Code and fix it. I'll simply ask my dev agent to align the LWC style with the Aura component. And there we go. Let's check our changes. As you can see now, our 2 components look nearly identical. We've successfully completed the Aura migration to LWC. While this took a couple of attempts for a single component, you can regroup some of these prompts and create custom rules to speed up the process as you iterate over your component. That's it for today. You've learned how to migrate Aura to Lightning Web Components. We've looked at the required MCP tools and how they are chained together. Then we saw a practical example of a migration with the Dreamhouse sample app. In the next episode, we'll cover how to set up and use custom MCP servers with Agentforce vibes. Thanks for watching. I hope that you found this content useful. Make sure to like this video and to subscribe to our channel to get more content like this. And see you in the next episode.